to explain the 11.1 task, which is for the demonstrating of the embedded system project. And in this project, I have made a project of smart kitchen, which is fully automated, and in which I have used three sensors and some hardware components and two microcontrollers, which are Arduino Nano IoT 33 and a Raspberry Pi. The three sensors are temperature humidity sensor, which is DHT11, weight sensor, which is HX711, LPG detector sensor, which is MQ5. And the hardware components are one microcontroller, the load cell, and the DC fan, and an adapter of 12 volt. Now I am going to explain the integration of the sensors and the hardware components. Firstly, the DHT11 sensor is directly connected with the Arduino Nano IoT 33, and the microcontroller is also connected with the Arduino Nano IoT 33 directly. After that, we have integrated the temperature humidity sensor with the microcontroller, and the DC fan is connected with the microcontroller, and we are giving the external power of 12 volt from the adapter, and this DC fan is of 12 volt. And this whole procedure is working according to the temperature humidity sensor. Like, if the temperature and humidity level is not maintained in the kitchen, then it will work accordingly. Like, I have set the uh, temperature humidity level. Like, if the humidity will go above 70 degrees Celsius, then it will start rotating to maintain the temperature of the kitchen, and if it will come below 70 degree, then it will stop rotating, because the temperature humidity level is maintained of the kitchen. After that, here we use the load cell for the weight of the cylinder, and this is the load cell of 50 kg, and the sensitivity of this load cell is very less. Like, if we put the weight nearly 40 kg on this load cell, then only it will give the correct readings. And it is connected with the weight sensor, and weight sensor is connected with the Arduino. Actually, if we put the mm, cylinder of 40 or 45 kg nearly, then it will show the correct readings. And firstly, it will sense the readings of the load cell, then it will give the accurate reading. It will show the accurate readings to the terminal. And after that, we have used LPG detector sensor, which is directly connected with the Arduino, and this whole process will work together only with the Arduino. After that, the data of these all sensors will store in the Arduino Nano IoT 33, and which will fetch the actually, after, like, we are using the Raspberry Pi, and which will placed in the central office, because we can see the kitchen condition from the central office only. And if we connect the Arduino Nano with the Raspberry Pi, then it will fetch the data from the Arduino, and it will show on the GUI which I have created on the Raspberry Pi. In the upcoming parts, I will show you the my GUI which I have created. And now I am going to show the working of the smart kitchen with the Arduino Nano first. So here is our code, and now I'm going to compile this to show the output. Here you can see the accurate readings, like weight is 0 kg because we have not put anything on the load cell, so it is showing 0 kg weight. And gas status is safe. And here are the temperature humidity level readings. See, here is 64 degree. Now I'm going to blow the air to the DHT11 sensor to increase the temperature. See, DC fan is working accordingly when the temperature is increased. Like here is now 83. Now it will slowly and gradually it will come to the normal temperature on the 70 degree, then it will stop rotating. We will wait for the normal condition. See, 70, and it stop rotating. See, here the temperature and humidity condition is normal and fan is stop rotating. Now I am going to show you the how the data is fetching in the Raspberry Pi. Now we are connecting it with the Raspberry Pi, and the sensors are working successfully. Now we are going to see this. Here is the code of the Raspberry Pi, and now we are going to run it. Here I have created the GUI. You can see here is the home button. See, the cylinder weight 0 kg, LPG gas safe, and here are the temperature humidity level. Now I am going to blow the air again. You can see temperature humidity level is fluctuating and it is increased. Now slowly it will come to the normal condition. Wait, 70, and it is stop rotating. So here it is successfully working. Here I set the button for the dark theme only. Now here I have added the function that if condition is not normal, like LPG is leaked, or the cylinder condition is not normal, or if the temperature condition is not normal, then it will trigger a notification through the mail. And for mail we have used the http protocol, uh, like API key, to send the notification. So currently the conditions are normal, but I have made a function in the GUI to test the mail notification. So I'm going to show you like how it is working. So here is the test notification. Now I'm going to send the test notification. See, the test notification is triggered, and here is written the smart kitchen system alert, gas status safe, temperature level is here, and cylinder weight is also here. So here it is working properly. So this is all the project I have made, and it is working properly. All sensors are all working properly. Now I'm going to explain the codes. Firstly, I'm going to explain the code of the Arduino. So here is the code in which I have used the two libraries, like for DST temperature humidity sensor dst.h, for weight sensor hx711.h. Here is the pin defined for the temperature sensor 5. Here are the pinouts for the motor driver, and here is the pin for the gas sensor, which is analog 0. Here is the pinouts of the weight sensor. And now after that, here we have set the thresholds of gas, temperature, humidity, and threshold of the weight sensor also, and the load cell which is connected with the weight sensor. And this notify function we have made for the notifications, which will show on the serial monitor. And after that, it is initializing the serial monitor. This is initializing the DHT sensor. This is initializing the weight sensor, which is HX711. After that, this function is resetting the scale of the load cell to the 0 after tearing the load cell. And here we have made the output of the fan according to the pinouts of the motor driver. And here we have made a void loop function, like it will detect the LPG. This is for the LPG gas sensor, and which will detect the LPG, like if it is leaked or not. It will work according to the thresholds which we have set already. And here this is for the temperature and humidity monitoring. Now after that, it is made for the notification for the temperature and humidity. Like it reads the temperature and humidity data from the DHT11 sensor. If it exceeds the set thresholds and no gas leak is detected, the fan is turned on. So it will work accordingly here. And if the conditions are normal, the fan will stop working. And in the last, we have made the function which prints the fan status based on the kitchen condition to the serial monitor, which displaying the temperature and humidity and gas status. So this is the entire code which I have made for the Arduino Nano IoT 33. Now I am going to show the code of the Raspberry Pi. Here is the code of the Raspberry Pi, in which I have import the 5 libraries. Like first one, requests, is for the HTTP requests. This is for the custom integrator window, and the time library is for the delays. The threading library is for fetching the data from the Arduino, and the serial library is for the serial communication. Here we have made the self title of smart kitchen, which was showing on the GUI. After that, here we have set the appearance like dark, which I have already shown on the GUI on the left side. After that, this is the grid layout of the main window. And further, we have set up the navigation frames on the row 0, column 0, and all accordingly. We have also made the navigation buttons like home button. We have made sensors button, notifications button to send the notification. So this is the this is function for the notification navigation buttons. This is the menu for the dark theme. We have made appearance mode menu. We have set only dark theme in the GUI. Here we create the frames for the content and home frame content. Like here is written welcome to smart kitchen in the bold letters, size is 20, which was showing on the GUI. This is also similar. And on the home page we have added the sensors and action buttons, like to monitor the sensor, to check the notification, and all. And we have made the sensor frame content to see the sensor readings. Again, the size is 20 and weight is bold. And here we have set the threshold of the cylinder weight, LPG status, and temperature humidity level. And here we have made the notification frame content to send the notifications. And here also we have made the send test notification button to see the test notification. After that, this function we have made for the to receive the status updates from the Arduino through the UART communication protocol. This includes the gas level, temperature, humidity, and cylinder weight information. After that, like this is for the background thread which is fetching the data from the Arduino. And at last, this all we have made for the e- email notification, like it will send an email alerts when unsafe conditions are detected. For example, if a gas leak is reported or the temperature and humidity exceeds safe thresholds, then alert email is sent. So this is the code of the Raspberry Pi. You can see. Overall, the Raspberry Pi codes acts as a central controller that continuously monitors the conditions of the kitchen and display them on a GUI, and sends email alerts when dangerous levels are detected through the sensors. This integration with the Arduino based system provides real-time safety monitoring and real-time safety and alerts for the kitchen. So this is the entire code I have made, and whole project is working. I have shown you already, and one last uh, compilation I am going to show you. See, the fan is working properly. Readings of the other sensors are also coming properly. I have already shown you. So this is the whole project I have made of the smart kitchen, which is fully automated. Thank you.